Yes, thank you.
Enjoy.
Okay, Julia, I think you can start.
Okay, well, let's see, can I share my screen? Yes, I should be able to share my screen. Give me a moment. So last Thursday, I got asked if I would provide a kind of an overview of what we've been doing, what we've done, and what we've been doing in regards to DPUs and such devices. And so I whipped up a quick presentation. And I'm Julia Krieger. Hopefully you can see my presentation. Please smile and nod and wave and so on and so forth if you can. No, yes, yes. That's a yes, okay. So my name is Julia Krieger. I am Senior Principal Software Engineer with Red Hat. Now, I say I work with Red Hat, but this is a community-oriented presentation because this is a community forum. So I wanted to make sure that this is very clear. I'm not talking product.
I'm sorry, Julia. I am not seeing your presentation.
I actually lost it as well. I saw it at the beginning and then lost it.
How about now?
I'm not even seeing
Nope.
indications from Zoom that it's
Wow.
attempting to share your screen.
Yes, now it is.
Okay.
Perfect.
Okay, that's weird. Okay. Now I can't see in your wonderful faces. So this is a community-oriented presentation, and I want to try and kind of provide an overview of what we've done in the past, in Ironic specifically, and kind of try and provide some background information. If I can take questions at the end, I have a little Q&A section. I can also answer questions in line. It's kind of up to you guys and how you want to handle it. And other than that, I guess I'll get started. So 3 basic buckets of information. I wanted to provide a quick 10,000 foot overview. What is Ironic? How is it used? Kind of some background to the original SmartNIC support that we worked on with Mellanox a while back. And kind of this ties in with GPUs a little bit. There's a common thread in there that I want to make sure that I highlight. And I also want to take a few minutes to cover what we see as our forward path in terms of Ironic as a project, and also trying to keep the door open for other integrations and capabilities. So that 3,048 meter overview, 10,000 feet. So for those of you that may or may not be aware, Ironic is an open source project that manages bare metal infrastructure. It provides discovery, lifecycle management, and including provisioning, maintenance, and decommissioning activities for a bare metal machine. And this project started in the OpenStack community a long, long time ago. Jay wasn't kidding about a decade. Ironic's 11th birthday, I think, is this summer, or has already passed. I don't remember. Originally, this was a project that spun off of the Nova Compute project to provide a bare metal instance, a physical machine that's a compute virtual machine. But this software is now used to facilitate bare metal server deployments, providing whole machines to a user as requested, when requested. And we've also spawned multiple sub-projects and integrations. And one of the original integration was the Nova Vert Ironic driver. But then we also have Bifrost, Metal Cubed, or Metal 3 is also spawned off of the Ironic community. Metalsmith is another tool that got created as part of our work. And then the Kali Ansible community also uses Bifrost directly to facilitate machine provisioning. And our approach is kind of a standards-based approach. We use things like IPMI, Redfish, PXE, Virtual Media, which is semi-standardized in Redfish, to facilitate deployment of physical machines. We also have a whole vendor class interface where vendors can write code and have their own drivers. And these drivers can handle things that, like, a really good example is on some vendors, you have to be aware of if there's a configuration job running. And if that configuration job is running, you can't apply different configuration or you have a conflict. So some of the drivers out there do exist to navigate some of these aspects and also add vendor value. And that's kind of what we've done as a community is we've standardized the interfaces as much as possible so that the big tasks that are achieved are entirely standardized, but we also have a pass-through so that vendors can still invoke a specific action or thing. A good example is setting an IPMI raw command is a vendor pass-through. It doesn't exist on things like Redfish. We have a variety of ways to deploy a machine. We support Kickstart, Ansible, RAM disk deployment, which is the concept of, oh, you put a RAM disk, I don't need to worry about this thing anymore. We do disk and partition images. We also do things like cleaning of the machine and removal of the state data, because you don't want to take a machine and deploy it with someone else's data on it. That's very, very bad and frowned upon. And we provide customization points in the form of what are called hardware managers. And I'll cover this a little bit more in a moment, but the idea is basically this is where you get to hide other business logic. And so we also have this model of steps, and it's important to kind of note steps before hardware managers. Steps are the process in which we take to execute a process of cleaning or deployment of a physical machine. And they come from a union of information supplied by the user, the drivers, and the hardware managers that might be running. Steps can be overridden. They can also have arguments attached to them depending on the use case. Like cleaning, you can't supply specific arguments because that's a fully automated operation. Unless you're asking for a manual cleaning, and then it's not a fully automated operation. So hardware managers are code. They run in an Ironics agent. Jay Faulkner actually, I think, wrote the first hardware manager. Thanks, Jay. And they're primarily used by larger scale operators to perform specific important tasks, like forcing firmware updates or verification of the machine state to meet their business standards. By default, they're not user interactive. They can expose steps which can be invoked by a user to have logic customization, such as I need to perform a specific firmware update. To date, we have our stock hardware manager, and then we also have a Upstream carries an Intel CNA hardware manager to disable LLDP collection on the card itself so that we can capture the data because we have a whole inventory and information collection mechanism. And then we also have a NVIDIA Mellanox interface to help aid identification of a device and also provide a firmware update mechanism. So any questions on the high level context before I move forward?
Julia, quick question.
Sure.
Everything, as I see here, is kind of command response based. So whether it's IPMI or Redfish, there is no intent base. So failures, descriptive deployments, all of that is probably on the higher level up, right?
That is handled on. So the way to think of steps are it's the order of operation in which to execute to achieve a task, and they can be dynamic based upon the data collected from a machine when it's preparing to deploy. A really good example is figuring out which boot device is the right device dynamically, because you need drivers to actually understand that in certain cases, or you might have preferences. And so you may need to change the machine, and depending upon that state, you may need to take additional actions. And so what steps are is a order of operations that is determined by Ironic itself to perform the action. So essentially, user says, I want to deploy this machine. If that matches a deploy template, or if it's just the stock deployment command, depending on what the user said to do, then Ironic takes the steps, the sample steps, or it takes it relies on what are called basically default steps and attempts to achieve the goal of deploying the machine.
So one thing that might shed a little bit of light on this as well is that Ironic sort of operates in two contexts, right? Like when we're talking about Redfish, IPMI, and that standards-based interactions, we're talking about the out-of-band controller. We're talking about things you can do even when the node's shut off or doing other things. But when we're talking about hardware managers, we're actually talking about code that executes in band on the device as a provisioning action. So for instance, your question about dynamic steps is the hardware manager interface designed so that you could write a hardware manager that would say detect an NVIDIA GPU and automatically add its steps into your cleaning process if it detected an NVIDIA GPU on the system at boot up. There are a large number of examples of how to do this, and they're all in the Ironic Python agent repo under the examples directory. And so I suggest you go look there. And also NVIDIA has code that's actually written to do this on Mellanox GPUs. Chris Krell, I believe, is the one who's working over there on that for y'all. So that sort of helps to kind of know the two areas, right? We've got the standard based stuff where we're sort of in a little bit of the box, and then the in-band stuff where you can do basically anything you can do in-band on a Linux system.
Correct.
Hopefully that's helpful.
One correction, that is I think you meant DPUs.
Yeah, I
or-
mean GPUs probably.
I mean
because,
GPUs. I just picked a random piece of hardware, and we're talking to people from NVIDIA, so I went for a GPU. Okay, I've got.
No worries.
I'm a gamer. I have NVIDIA GPUs in my house. I don't have any of their DPUs in my house, so you know, you can feel free to fix that if you want. I got plenty of servers I can plug them into, but you know.
Well, you can use NGC for that. Don't buy don't buy personal DPUs. We'll fix you in another way. But one question for the group actually. We reviewed Ironic. I'm sure that everyone here heard about it at some point, or used it even. We have a bunch of DPU vendors here. We have Marvell, we have AMD, probably Intel. I really want to ask you folks, have you tried using Ironic to provision a server with DPUs or just provision DPUs?
It's not a fair question, Gal, because Ironic has a lot of competition in the market. There are a lot of bare metal orchestration provisioning systems. Just to name a big ones, and probably Julia, Jay, you know very well the competition here in the space, but Canonical Mez and stuff. So I think that what we need to, at least from my point of view, what we need to focus is not on the orchestration system, because everybody is going to pick their favorite ones in their data center. But I think we need to focus on how we integrate the new hardware, which is DPUs or newish, into any orchestration system. So
In
we
what?
can actually force vendors to actually implement the good Redfish APIs instead of RShim interfaces that some vendors chose to do without naming them. That's I think they might focus, and not specifically on the implementation.
Well, I don't disagree. I don't disagree. But we are in Ironic call, and we are talking about specifically Ironic. And I just wanted to ask if any of the vendors have experienced with specifically Ironic on their hardware. If they tried it, not if they chose it as their optimal solution for everything. Just if they try to utilize it, work with it. I can say that in NVIDIA we did.
So I feel like we should probably carry on. I do agree with Boris completely. The problem, and this is a classical open source community problem, you don't know what you don't know because people don't talk to you. So one of the things we've run into is the closer you get to infrastructure and revenue generation of via infrastructure, the less people actually talk to you. So that's this is one of those things where it's like, we've heard people doing it. We've heard people going, well, I did this and it worked. And then we kind of go, you did what? Okay. Another whiskey, please. Those sorts of interactions, which are not great for our community, but it's a data point for us. So if I'll go ahead and kind of talk about the SmartNIC support that we originally had, so you kind of have some background, because I know some of the Mellanox and NVIDIA folks have worked on this in the past. And then I will dive into kind of the things that we're doing in the future to kind of also enable better integration points. So does that sound good?
Yep.
No objections.
Okay. So the original idea with SmartNICs was to provide support to provision bare metal workloads with network attachments. And the reason this is important is because I guess there's two aspects. Bare metal machines are never going away. Or at least in some contexts, they're never going away. And there is also a competition in what's called separation of duties between the network team and the server operations team. Very rarely do we actually see this being the same team in most enterprises. It's usually delineated with a lot of separate rules and separate ways of handling things, and lots of mistrust, which is really unfortunate, but it's a thing. Anyway, the original work to support SmartNICs in this case, so that we could support deploying physical machines with network attachments with a SmartNIC, was driven by Mellanox. And it consisted of two parts. The first was to alter the power workflow to enable the attachment process to take place. So when we talk about orchestrating a workflow, we normally would go power on, power off, make sure the state is for basically the PXE environment's in place, or that the virtual media is attached, and then we power on the machine. And in the case of the Mellanox NICs, we needed to attach that machine's networks before we ever did the power actions, because if you have a machine that has been touched by an untrusted tenant and you are not aware or cannot verify the sanity, or not sanity, that the machine has not been infested by malware, basically is the best way to put it. Infected. If you can't verify, if you don't basically want to take what's potentially an infected machine and put it on a network with generalized workloads. So the whole idea also was, when we tear it down, we need to make sure that the machine is not on the same network. So we need to isolate the machine and perform various cleaning actions to ensure that there's not data there present anymore, and that we've done as much as possible to remove and clean and sanitize the machine. So essentially, all this work was just a different workflow where we power on the card or power on the machine, the card's already on, and we hold the boot process so the machine cannot proceed. Basically say boot to firmware instead of booting to network. And we wait and watch the network service to see if the card is up and running, and if it has made the attachments, and if so, then we move forward and let the machine proceed. And this led to some challenges. We avoided firmware and lifecycle of the card specifically because it was a clear friction point we were running into. And we were seeing competing forces between software and hardware vendors and the card manufacturers, because some vendors were not ready for the concept of, it's not firmware that I certified my lab to be running on this card. That's entirely under my control. So that caused a lot of friction, and we actually had someone scream out in a meeting, it's like, you will not put firmware on a card that we did not certify. And you can imagine how that meeting went. Luckily, the world seems a bit more calm and sane at this point. But essentially, this was the whole concept of a machine inside of a machine. And is that data running on the card firmware or software? And that was an additional friction point that I think people kind of had to emotionally work through. So we recognized this was not a place for us to get into, at least at a community level. People might have been doing some other things, but essentially that was where it was at. The other issue that existed in this scenario was that it was designed around the use of OVS, and OVS running on the card. And OVS in that context has networking bottlenecks, and basically you can't get full performance of the network in that case, because you end up having a northbound router that you have to go through. And ultimately, this entire functionality was modeled to work only in a fully integrated OpenStack deployment. And most operators tend to run partial deployments, or they run 5 of 6 services, or they pick and choose the services they need for their environments. So it doesn't always work out the same way. And there's also still that separation of duties line. Like, is it really the network or is it not? Sort of question and challenge. Some operators are very comfortable with network automation, others are not comfortable at all, and it's a challenge in this entire space. So the result, where things kind of were left with this functionality, was the adoption, as far as we can see upstream, is fairly minimal. We don't believe anyone has actually productize this use model. We know some people have used it, deployed it, they've been happy. We know some people have done some other crazy things, and it just worked, but it's still we don't think anyone's really truly using the functionality, unfortunately. We think it was probably a little too early. The use of the firmware and software management has largely been disjointed, and that's in line with data center operators and GPUs, where we tend to see the operator approaches being disjointed, and we only tend to see them align when the use case aligns. So like if you have high performance computing and you're using GPU workloads, then you're going to probably have something to make sure that your firmware is the way you need it and everything's ready and to roll. And you may be having to change it per workloads, at which point you have additional business logic that you need to handle. So you can imagine how this starts getting complicated based upon individual site requirements and workload requirements. So one of the other things to note is hardware operator interest is very strong around the network attachment aspect and making sure that we can attach a machine to the right network and not be able to expose the rest of the networking infrastructure to the machine itself. Only the actual VXLAN the card has been tagged off to, or that the workload has been tagged off through the port. Any questions?
Question, comment, Julia.
Sure.
So I think, at least for me, it's a little bit confusing because on one side, we're talking about the bare metal provisioning, lifecycle management, firmware updates and stuff. On the other side, you're talking about network attachment and network provisioning, whether it's, OVS, VXLANs, whatever we're doing. So for me, this is kind of mixed functionality. Is that, or was that an approach so far in Ironic to do both kind of?
So we have orchestration tooling for. Okay, I'll mentally take a step back. We have orchestration tooling so that we can orchestrate and say network service performance attachment, and it's just a plugin. Deployment workflow, do X, Y, and Z. The user requested that we update the firmware, and they sent through the things that they want in the step order that they want. Okay, we'll do that order and apply the firmware updates. That doesn't work in every single case, and it's very specific based upon vendor and based upon the hardware that they have in their environment. And so it's one of those things where we support the interfaces to apply some of these things. We support genericized interfaces to do a lot of these things. The challenge before us is when you start combining different elements, getting to a point where you have everything you need to support your business case and your workflow. And so the bulk of our operators tend to be raw infrastructure operators, large labs, high performance computing, and just people doing basic installation of clusters. So it's kind of like we have this whole width and breadth of functionality that has evolved and been developed over years to support a variety of use cases. And we think we need to go a little bit further for DPUs and SmartNIC, or DPUs in general, and provide a bit more functionality. But we also are seeing the way people are approaching these things starting to shift, and we need to both accommodate that and ensure that we can enable it later on. Does that kind of make more sense?
A little bit, but let's move on and maybe
Okay.
it will be clearer
I
later.
mean, I would almost say, like, Julia's downplaying this a little bit, that this is the strength of Ironic, right? Like you talked about, competition such as Mass or Cobbler, and a lot of those pieces are not going to have the deep integrations that Ironic has with trying to manage your infrastructure as a holistic piece with, some of the other OpenStack tools or other things you can plug into Ironic. Whereas many of the other things are just focusing on one specific enclosure. And for me personally, I'm speaking for Jay, I'm not speaking for G Research or for Ironic or anything like that. I'm particularly excited about the possibilities that DPU presents of helping us to thin that stack, where right now Ironic maybe has to talk to an external network service that knows how to talk to 5 different vendor switches. In a world with a DPU, maybe Ironic can have its own smaller service that talks to something similar like that, so that we're taking our claws of an Ironic or an OpenStack installation retract a little bit from the network operations center, which, as Julia said, is maybe the number one friction point for operators of Ironic in the real world.
Makes total sense, Jay. And one more generic question, Julia and Jay, maybe even on the previous slides, but on Ironic is always the issue that comes up is scalability, especially with now telco and cloud. We're talking about 100,000 nodes. So what is the scalability of Ironic?
I
that
personally operated a cloud that had 100,000 nodes in it.
with everything?
I cannot attribute the name. They're under NDA. Many of our largest installers are under NDA. As Julia sort of pointed out, the closer you get to the infrastructure and people making money, the more quiet people get about it. And so there's a cabal of senior Ironic developers who have to sit here and stew, because I know the name of 4 different places that I can tell you that are at that scale, none of which I have the freedom to say to you out loud. So like I can promise you, I'll sign a greeting card that says we scale up that high, but we don't have logos that are willing to step forward and say this is us operating at this scale beyond the few who've spoken at the summit. And I believe my previous employer spoke at the summit but didn't give scale numbers. And you might find that if you go and watch a summit talk about someone talking about operating Ironic or operating OpenStack at extremely high scale, that's going to be 6-digit numbers of servers, probably 7 to 8-digit numbers of cores.
Makes sense. Thanks, Jay.
So the other thing to keep in mind, especially in the telco space, is you end up in varieties of use models. And so I know a major US telecom runs stacks of roughly 80 machines. They just have like 1,000 stacks of 80 machines spread across the United States. It's not a bad thing. It's just the way that they operate their business, and that they have found that addresses their concerns and their risk management and their operating requirements. And so, yes, they have many Ironics in their environment, but they're also isolated. They're specific for those clusters. So hopefully that answers a little bit of the question and provides a little more clarity.
Thanks.
Okay, forward path. So we see some emerging needs. We're finding infrastructure operators are in need to support automation around more complex scenarios with multiple devices. In other words, you have a server, but you have additional devices hanging off. And this sounds a lot like the external power supply of a DPU. But I think one of the folks that presented the whole thing to me was, well, I may have some things that relate to the automotive space. I might need to power them off as well, so I can do X, Y, and Z. And that's kind of where this is a complementing model for us. But the key thing to keep in mind is the same basic problem is there. I have a parent thing. It is in charge of other things in some way, shape, or form. And I need to somehow orchestrate the 2 things together, or the 18 things together, so that I can achieve my goal. Another thing that we're also seeing is that vendors are much more willing to kind of approach the software firmware issue that exists when running computers inside of computers. I think it's probably people have grown a little more comfortable with the concept over time, especially as BMCs are becoming more and more just Linux machines on the inside of machines. So we're also seeing customer and partner pressure starting to drive upwards of people wanting and needing some of these things to be taken care of, or at least addressed, or a path so that they can have the automation functionality. And infrastructure automators or infrastructure operators who are kind of Ironic's primary customer just need a path forward to get their job done, to tie things together and move on with their lives. So we have a tendency to put building blocks in place. we tend to look at problems from a holistic standpoint. And one of the things that we'll do as a project is we see the people walking this path, we'll try and pave the path. Because obviously they're walking the path and it makes sense at that point. And we just have a really long history of doing that, trying to make it easier because quality of life is the most important thing for us. So we're actively working on extending our data model interactions to support the declaration of what are called child nodes. And a child node may have multiple other devices, each with their own independent management controller. They're not a specific node that can be deployed indirectly, but you can always say, I want to deploy this node directly. You don't see in the normal server list, but it's a thing that we're working on to try and at least tackle some of that, because one of the problems we also see in Ironic is if you have a fleet of bare metal that you're handing out as workload machines, if you try and put a DPU card into that inventory, you can't put a general workload on that machine. Someone's going to get really surprised if that happens. So obviously we want to delineate that. And so that's kind of partly where this entire concept comes from and helps with. The additional thing that we're working on is this concept of extending steps so that you can declare them with a child node or nodes. So you can say, I want to power on, I want to power off, I want to perform this firmware update action against the child node in sequence with an operation on a parent node. So if you imagine I have a bare metal machine I'm attempting to deploy for a workload, and it has a DPU, the idea would be, oh, we can step through, oh, there's a DPU, okay, the S user has requested this template, okay, we send the appropriate commands off, and hopefully at the end of the day, the machine comes up, everything's the way that user has requested it via the steps that they supplied or that they templated. We're also adding some additional workflow and logic into our steps interface. We're adding what's called a hold step. And the idea here is we've recognized some people are going to have processes that they're going to need to execute or that are disjointed from a lifecycle orchestration system. And so the idea here is we want to have the ability to say, stop the process, wait a minute, another tool can come in and validate that things are heading the right direction, or that the card deployment service on the actual running on the machine has completed or whatever. We're trying to be abstract and high level at this point. But basically that's something we're hoping to get merged pretty soon. We've also looking at introducing a service command verb, which is more of the concept of, oh, I have a deployed machine, I want to change it now. This is still under development and it's loosely related. The idea might be here might be, I need to update this card, or I need to perform administrative actions on this card via the central system. And there's also been some discussion of a specific command execution interface. This has come up a few times, and it's kind of boiled down to we just need to do this. Someone needs to put a patch up. Just no one's done it yet. And so one of the things I want to kind of take note of is, why do we care about OPI and why we're here kind of talking about what we have and what we've been doing, is we care about the network attachment functionality, because that is critical to a lot of our users and operators, because these solutions right now generally rely on telling the SDN to update, or rely upon logging into the switch and making configuration changes. And customers have varying levels of comfort with such functionality. And ultimately, our end users need a bunch of functionality if this hardware is going to ever hit mainstream. We have a lot of general purpose cloud computing users. We have labs, test environments that have distinct resource allocation needs and workflows that they need to adhere to and work with. And there's also the whole aspect of initial infrastructure deployment. So if you're deploying, say, a cell site, you might have certain steps that you need to work through, and you might need to do some additional things, but at the same time, that's not really a continuous management unless you have to change something drastically. So kind of the thing that we're here for is just to enable operators. So I have some canned Q&A questions. We can walk through them, or
Just a couple of questions if you don't mind, Julia.
sure.
Just to clarify, the Ironic approach is always out-of-band management of DPUs, so you need to have 1 gig additional cable connected to the DPU, or you somehow operate through the platform or server BMC where the DPU is plugged into. What is your view on this now and going forward?
So our view is generally going to be the out of band is preferable. We foresee probably a mixed approach depending upon the card and the scenario. And I think that's an area we kind of need OPI to help drive some standardization. Obviously, out of band is probably preferred because the bulk of the operators that we work with need to have high security isolation for the actual workloads.
But
So
when you say out of band, just to make sure, when you say out of band, you meaning 2 management cables, one
Yes.
for the server and one for the DPU.
yes,
It doesn't have to be to management. It can also be on the in-band port of the DPU and not a dedicated of the server and not the management port of a server. That's also a common approach that we see a lot.
yes.
This is interesting to me because it maps a lot to what we saw with firmware updates and BIOS updates in general. Or, you know, we talk about been doing this for a decade, right? Like the hardware management interface was written by me like 10 years ago to handle this for BIOS updates, because with IPMI being the predominant technology used, there wasn't a reliable way to update firmware out of band. Some IPMI supported it, but it wasn't something you could rely on. So you ended up having to have these bespoke tools for each vendor. And that didn't get cleaned up where we were able to do a really good job of updating firmware until standards bodies stepped in, until we had things like Redfish, until we worked closely with the DMTF to have them like understand what capabilities a project like Ironic needed and help us write a profile to advertise that. So I sort of think your answer is reverse of how we're used to having this conversation. Ironic, we're more used to building Legos of all shapes and sizes because we don't expect the hardware vendors to come at us with a unified interface to begin with. We expect it to be some people are having you have to combine, you know, server management interface and DPU management interface with some in-band. Some are going to be just one or the other, and we understand that's how the landscape is going to look. And my hope in coming to this meeting was that, you know, just like the DMTF helped straighten a lot of that out for Redfish, y'all may be in a unique position to sort this out for DPUs and to help us come up with a standard. I will say it this way. I don't have a strong preference as to what method that y'all might would land on for managing these devices. I care that there's only 1 or 2 and not, you know, 10. And you can see this having matured through Ironic over the last 10 years with DMCs, of where, you know, like you were asking if anyone run hardware. We had Dells running third-party CI in our environment, getting provisioned thousands of times as part of our testing, but they don't have to do that anymore because the standards took that work away from them and made it where we test against the standard, they test against the standard, everyone's happy. And so, like, I know that that's not the question, but that's my chance to like shim in Jay's agenda of like, please give us a standard to integrate with. We don't necessarily even care exactly what the standard says to do, as long as it says to do it and most major vendors do it, because then we're going to be able to implement it. Otherwise, we're going to have to go the path we've always gone, which is Julia describing the different shapes and sizes of Legos we're building to let operators assemble it together to get a firmware update done in whatever crazy way ends up coming out for the second gen of this hardware.
So another thing that could also be done is Redfish. It could be a subsystem of the primary system, and I believe that's in the scheme. You can have multiple systems under our compute.
Yeah, that's a new.
Well,
DMTF
it's compute
edition for
systems,
it.
computer
Yeah,
systems.
That's a new DMTF edition for it. Yes.
Yeah, so that's entirely possible as well, and our model allows that to be configured too. So it's not something we're really worried about, but obviously a preferred path is that one standardized way would make life a lot easier, as long as it's secured so that we can put untrusted workloads on the physical machine.
And
that
a
is-
follow-up question
that's-
on this, if you have the out-of-band management, do you do automatic discovery of the networking endpoints like DPUs, or you have a static list pre-provisioned of all the MAC addresses or whatever?
So we,
building your own?
if someone points us at a Redfish endpoint, we will retrieve the MAC addresses if it's supported by the device. I don't think that ever completely got standardized by DMTF.
For example, Redfish supports SSDP discovery protocol, for example, to automatically discover Redfish endpoints.
Yeah, we don't do that. A lot of times we're not on the same physical network. We're usually divorced, and there's usually firewalls in between us and the BMCs. So we have the ability to extract MAC addresses from the BMC if it can show us the addresses. We don't do SSDP as if we're attached to the same local network.
I'll also say that many of operators who I've spoken to consider doing that generally an anti-pattern, even if the technology exists. In every environment I've worked in and the downstreams I work with actively now, even with the discovery capabilities there, they prefer to have a scanned in inventory sheet that then they can have automation and ironic compared to the reality of what they were sold. Simply because if you buy enough servers from a vendor, one of them is going to be missing a disk, or something of that nature. So we do find there are operators who prefer the declarative to discovery based methods that they can use kind of the state of the machines against like the inventory or shipping manifest as a validation step for their purchasing, even not even caring about the fact that it has a human in the process.
Yeah, we've also seen operators start with discovery of machines through like static PXE environments and have that move all the way through an automated verification pipeline that, oh yes, we received the bill of goods we purchased. Now keep in mind those are operators running at the tens of thousands of machines scale. But usually that's the automate the processes that the humans have been doing in the data center sort of aspects. So does that kind of provide some clarity?
Yeah, absolutely.
Okay.
The last question that I had is Ironic going forward trying to deprecate IPMI and doing Redfish only, or still both of them are equally going to be supported?
We would love to deprecate IPMI. I think we would love that Redfish be the only path forward. The problem is that people still have IPMI. They still want to use IPMI, even with the giant security warning saying don't use IPMI. The challenge is that it is so ingrained and people are so comfortable with it. And at the end of the day, it's kind of simple, even though it has a giant security hole, that people just don't care.
Like,
And
I
that's
wouldn't tell people to run it, but like there's very little cost for us to carry the code, right? Like
Yeah.
we aren't getting a lot of complaints about quirks and new IPMI BMCs, right? Like we've squeezed most of the quirks out of the ones that already exist. It's sitting there, the code exists. I'm with Julia that I don't want people to use the driver, but I also don't want to make anyone angry that their 5-6 year old hardware stops working under Ironic when it's been happy before. So like,
Yeah.
I would be a fan maybe if we wanted to merge something that like puts a bigger warning sign on it or prints a warning at conductor startup that you're doing insecure things. But I think you'd be hard pressed to get that driver even like a full deprecation message on it in Ironic anytime soon.
Yeah, we when I said that we have people running hardware labs, we have people that decommission supercomputers and run Ironic to provide general compute resources, and they only have IPMI because the machines were ordered 7 years ago. They shipped 6 years ago, but they still don't have Redfish. So that's kind of a common theme we see, especially in the more academic and research-oriented verticals of use.
That's clear, and I want to touch base before we end out of time. I want to touch base on the collaboration and open source between the two projects. So obviously we don't, I think we cannot afford ourselves only to do Ironic, but need obviously to support other orchestrators. That's obvious thing. And I really clearly hear your desire to standardize. I think we all support that as well, to have a single, let's start with protocol, data models, and if we can adopt Redfish, great, in the same way for all the DPU vendors, that's also great. From the code open source perspective, I've been thinking for a while, and we already started some very small work on creating a Python library. We call it a PyDPU. If I remember, Ironic is Python-based project, right?
Yes.
So I started to work on PyDPU. We published it on PyPy. So what do you think about creating a library, pip installable, that can be used by any project, including Ironic, that will provide all the interfaces, starting with lifecycle management and not just raw API Redfish stuff, but maybe we'll hide some of the diversity between DPU vendors or more complicated operations that we need, and will be generically available that everybody, not just Ironic, can pip install it and just work with DPUs out of the
I think that is ideal.
I'm not sure I agree necessarily. Like, one of the problems that we have with Ironic, and this can be a design constraint on the library you're talking about, like we're here chatting about it. One of the biggest complaints we get from operators in the real world is when something fails, that they don't get that much insight onto what happens to cause it to fail. The further away we abstract from the actual hardware, the more difficult it's going to be for us to communicate to operators what went wrong and how to fix it. So if we were going to funnel out some of what really, this is what Ironic does, right? Like this hardware orchestration layer, you're talking about the bits that Ironic does that other projects don't do as well. So this is core to what we do. Anyone can PXE boot a server. Some of the work we've done made it easy for anyone to boot with Redfish Virtual Media, but orchestrating the hardware and delivering good errors is like some of what Ironic has done historically. And I would maybe point out to the fact that as one of the early adopters of Redfish, we have one of the best Redfish Python libraries there are out there. We actually have an emulator that emulates Redfish that lots of other projects use for testing as well. So like, I don't necessarily think that's a bad idea. I think we need to be really cautious about how many of the details we hide behind a firewall, because we've got to be able to see past that to be able to instruct operators how to fix their environment. But all this
Yes.
being said, we want we want everyone to work together. Libraries are good and fun, but I would say don't necessarily discard that the Ironic and OpenM4 community in general might be a good first choice to stop by to help you do that design. We've done it before with Redfish. We've helped out with some of that. We're happy to be that, and we're not going to be greedy with our knowledge or what the results are. Like I don't care if someone uses Mass or Cobbler or Ironic or whatever, as long as they're provisioning machines and getting rid of human tool in it. I'm happy to work together to make all that there. So that's my concern with the library, right? Let's just make sure that the panes of glass in it are very clear and easy for the operators to see through, even with Ironic, or maybe even a layer in front of Ironic in front of it, so that they can still see and know exactly what's going on, so that they'll be empowered to fix it.
I think we would want to identify the specific actions that hardware operators need to be able to perform in that life cycle and sequence, and then provide the pass-throughs so that they can do the thing with the library on the back end.
Yeah,
I think-
absolutely. I think the same approach like we did with Python Redfish or C Redfish library, that has a little bit of session management credentials. In DPUs, we need matching what DPU belongs to what server, for example, right? So there are a couple of functionalities that everybody's going to need. This is what I'm thinking, right? Still, it's going to use a Redfish library because it's going, if we adopt Redfish, because it's going to send Redfish APIs for the DPUs. So it will be just using the same Redfish commands, but a few abstractions is absolutely, I think, necessary.
Yep.
Okay. We are nearing the last 10 minutes. I want to hear from other folks on the call if you have something to comment on, share. Do you feel like those sort of conversations, those sort of topics that are a bit, let's say, top down, are a bit more high level than the conversation we had so far are relevant to the forum, are relevant to your company, are relevant to the efforts that you're currently doing?
Yes, they are very relevant, and I'm glad to hear that.
Okay, that's good to know. Anyone thinks
Yeah, I
otherwise,
have
want
a
to focus
question.
on different area? Okay, go ahead.
Yeah, I have a question because when you are talking about the company cannot mention that is managing those hundreds of thousands of devices in their fleet. Is it like the devices managed or the platforms managed come from a single vendor, or it's the headache of managing multi-vendor, different server types, different generations, and so on, and that's what led you to that thinking of that the standardization is needed?
I think the answer to all of those is yes, that it's not necessarily an either or, it's a bunch of small things. You know, I when I think about it, and this is from an upstream developer's perspective to a certain degree, we literally had Dell, I think Fujitsu, Cisco, HPE, all actively running tests against Ironic because it wasn't standardized. The amount of human effort that took to cause that was being invested in running operational stuff and not in committing to code was huge. So like anytime you can take that amount of human tool and remove it from a situation, it improves the world. For our actual operators, quite frankly, IPMI was always that interface. If you went into a mixed, at least for me personally, the environments I saw, you go into a mixed environment that had Dell hardware, that had HP hardware, that had, you know, super micro gear, they're going to be using IPMI and they're not going to be using any of the advanced features of the BMC. And so like what I see it is less of a, we're going to take this operational headache away from people, and more as if we standardize this and we make a standard API, we're going to actually be able to deliver more of this functionality to the average operator, right? We're not just going to be locking behind this cool virtual media stuff only to people who have the money to buy homogenous latest gen hardware from a single vendor. And so like I don't know if that's what everyone was thinking, but that's certainly what I saw and grabbed a hold of as the big advantage every time we've gone to standardize this, is we've taken a feature or something maybe inherent to the hardware, maybe that took a large amount of configuration or domain knowledge to implement, and we take it and we make it accessible to smaller operators that they can get it for free. When I look at the cluster that G Research runs downstream, what I see is I see the equivalent cluster that I ran at scale at Rackspace for their cloud, except for instead of needing a team of a dozen people writing code to keep it up, they've got like 2 people and they're installing OpenStack from source. Like that's kind of, I view it as an accessibility play, right? Like the simpler we make this, the more standards based we make it, the more people get to benefit from that feature existing.
And so one of the things that you kind of hit upon is the size and scale. One of the things that is very consistent in the larger operators, and you can actually see this if you follow some of the folks from Cerner on social media, is they upgrade and tear down 1,000 machines at a time. That's not the entire scale of their cloud. They have to keep their infrastructure up and running during that entire time. So they're rolling through infrastructure, and they started moving to Redfish. But at some point, they also focused on least common denominator, which was IPMI, until they were comfortable with making that switch.
Okay. So we are at the last 4 minutes. Just want to give a bit of heads up for next meeting. So today we had, first of all, thanks a lot, Jay and Julia, for the talk. I love to hear that. We had some experience with Ironic and DPUs in NVIDIA. We didn't use any of the new things you developed, as far as I'm aware at least. Better correct me if I'm wrong. But I think we would love to deepen our knowledge there a bit. So thanks a lot for the talk and for preparing the presentation. It was useful for all of us. for next meeting, I wanted to dive deeper into the actual vote that we made 2 weeks ago, which was to narrow down on the boot sequence coordination between the host and the DPU, XPU, sorry. And I think that with the boot coordination and the talk that we have right now, that's a good path forward to talk about the whole ironic adoption and whatnot. So I think that would cover the next 1 or 2 meetings that we'll have. Please feel free to send me on private in
What
Slack,
do you mean, Gal, by ironic adoption?
redfish adoption. I said ironic?
You did.
Sorry, folks. I meant redfish adoption. I didn't even notice. Yeah, so the boot sequence and and the ironic talk that we have right now, we heard redfish comes up a lot in both topics. I think it could be a good path to reach that topic of a redfish support. Sorry
But
for the
we
confusion.
need ironic help. We need Jay and Julia probably. I started to create an examples of all the lifecycle operations that we need from DPUs, but because guys, you actually implemented that, maybe we can deep dive on actual examples and specifics. What operations you view and would like to see a common? Because saying we adopt redfish means absolutely nothing. We need to actually show the models, the commands, and say these are the only 5 commands that are common across all the vendors, that all the vendors feel comfortable implementing. So I think we should start with small examples. You can use this page. This is a very raw initial my take on the examples on the redfish that we're doing, but we need your help because you're actually doing this stuff. So what redfish interfaces you would like to standardize?
That would be great to get offline. If you can do some internal work and centralize the redfish APIs that you use and would like to see supported across vendors, that would be great input for the team, I think, as Boris said. Okay, so please feel free to send me topics that you want to discuss, areas you want to focus on in Slack, in private, in email, in any form that you want, and we'll try to find the time. The goal here is also to standardize and get the opinions of all the vendors and focus on what is important to you folks and to the community. So thanks a lot for today and see you next time.
Thank you. Bye-bye.